Hello, today me, Amin Al Jawadi, and my friend Saad Qaddoumi are going to be explaining our project about the four fundamental forces. One of the most remarkable simplifications in physics is that only four distinct forces account for all known phenomena. These four fundamental forces are the gravitational force, electromagnetic force, the weak nuclear force, and the strong nuclear force. These forces govern how objects or particles interact and how certain particles decay. All four fundamental forces are considered to be field forces. The electromagnetic and gravitational forces act over long ranges, while strong and weak nuclear forces only act at the microscopic level. First, we'll be talking about the two fundamental forces that occur at the macroscopic level, which are the gravitational and electromagnetic forces. The gravitational force acts between all objects that have mass. It also attracts objects together, and although it's the weakest fundamental force, it has infinite range, which means it does not get weaker with distance. The force of gravity pulls objects together towards the Earth, causing things to fall. Newton developed an equation to describe quantitatively the magnitude of the gravitational force if a certain distance separates certain masses. G in that equation is called the constant of universal gravitation. The value of G was unknown in Newton's day, but experiments have since determined the value to be 6.673 times 10 to the power of negative 11. Examples of gravitational force include the force that causes a ball you throw in the air to come down again. It also keeps the planets and moons in orbit. The force of gravity from our moon acting on the ocean causes tides. If the moon is in the south or in the north, there are high tides on the north and south, and low tides on the west and east. If the moon was on either the east or west side, there are high tides on the east and west, and low tides on the south and north.
The electromagnetic force is a fundamental force in nature which acts between charged particles and is a combination of all electrical and magnetic forces. Electromagnetic forces act between charged particles. Opposite charges attract, while objects with the same charge will repel each other. Many everyday forces are truly electromagnetic forces on an atomic level added up to a larger scale. For example, pushing a box exerts a force on it because the negatively charged electrons pound in atoms in the hand. Pushing repel the negatively charged electrons in the atoms of the box. Electric fields and magnetic fields involve these interactions. Electromagnetism is responsible for many very important interactions, such as chemical bonding. For example, the electromagnetic force holds atoms together in a molecule, causes friction, and attracts iron to a magnet. The most common example of an electromagnetic force is light. All light or waves in the electromagnetic field from gamma rays through X-rays, through visible light, and past radio waves, all of these can be examples of electromagnetic force.
The weak force is one of the four fundamental forces that govern the universe. While the other forces hold things together, the weak force plays a greater role in things falling apart or decaying. The weak force or weak interaction is stronger than gravity, but it is only effective at very short distances. It acts on the subatomic level and plays a crucial role in powering stars and creating elements. It is also responsible for much of the natural radiation present in the universe. Italian physicist Enrico Fermi devised a theory in 1933 to explain beta decay, which is the process by which a neutron in a nucleus changes into a proton and expels an electron, often called a beta particle. Examples of weak nuclear force include beta decay. During beta decay, a neutron disappears and is replaced by a proton and an electron, and a neutrino, or an anti-electron.
The strong nuclear force is one of the four basic forces in nature, the others being gravity, the electromagnetic force, and the weak nuclear force. As its name implies, it is the strongest of the four. However, it also has the shortest range, meaning the particles must be extremely close before its effects are felt. Its main job is to hold together the subatomic particles of the nucleus, protons which carry a positive charge and neutrons which carry no charge. These particles are collectively called nucleons. The strong nuclear force binds protons and neutrons together to form atomic nuclei heavier than hydrogen. It works in terms of guiding energy, which is also known as mass deficit. As an example, the strong force explains how the sun fuses hydrogen into helium. Protons are positively charged and repel each other. At the temperatures and pressures in the sun's core, two protons can get close enough that the strong force overcomes the electrostatic repulsion and burns two protons into highly unstable helium. Occasionally, one of the protons decays into a neutron, forming deuterium, forming reactions taking place until helium-4 is produced and the binding energy is released.
Thanks for watching and hope you understood something from this video.